Hello everyone. Today we will solve one of the Leetcode problem. Find the duplicate number. This problem says that you have given an integer array of nums containing n plus 1 integers, where each integer is in the range of 1 plus 1 and both are inclusive. What does it mean? It means the given array of integer containing n plus 1 integer. So it contains n plus 1 integers. So if this is the nums array I have, and this contains the range from 1 to n, that means total n type of integers, right? But the length of this uh, array is n plus 1. So that means there is one integer which will repeat, correct? And they are mentioning in the second line that there is only one repeated nums and we have to return this repeated number. Okay, so we can take this example. So here you can see the integer 2 is repeated element and we have to return this. But the condition is that you have to solve this problem without modifying the array and uses only constant extra space. Okay, let's take this problem and solve it. If we first talk about the brute force approach, so the first thing which comes into mind is sort the array. Okay, but it will take n log n time complexity. Second solution which will come into mind is create the hash map of frequency element data. It will take O of n time, but space complexity will be O of n. But they are saying that they want O of n but constant extra space. So we have to think about the optimized solution. Okay. First of all, this problem is not at all very intuitive. You have to aware in the interview, you have to aware of this problem before solving it. Okay, so this problem is actually linked to linked list problem. So it uses the concept of linked list and where we will use the fluid cycles algorithms. Okay, so let's first understand this problem. So if you look at this thing, you will see the integers, here is 1 2 3 4 2. Okay, and if I just write down the index in the zeroth index format, so it will be 0 1 2 3 4. Okay, for now let's consider that these numbers are pointers. Okay, so if these numbers are pointer, then this one uh, this one will point to the index 1. Okay, this 2 will point to the index 2. Okay, so what does it mean? It means that we know that the numbers are in the range of 1 to n only, right? So, and this number will definitely going to be point to some of the any number, right, from the remaining numbers. Okay, and we will follow this path. Okay, and while going through it, let's move ahead. So this will point to this element, this, and 4 will point to this element, and this will then point to this element. So when you will do this exercise, you will get to know that there is a cycle formation. And in the linked list, we know that whenever the cycle formation happen, uh, we use the Floyd cycle algorithm to determine the first point. And you will also get to know that the cycle formation will happen at the point where the duplicate number are there. So if you see, we can see here that the 2 number is repeating, and at this 2 number there are 2 pointer uh, uh, which is pointing to this number, right? So we have to determine this. Okay, so if I try to create the linked list of this problem, it will be something like this. So we have one element, okay, and one will pointing to the element number 2, 2 is pointing to element number 3, 3 is pointing to element number 4, 4 is pointing to element number 2, and 2 is then again pointing to the uh, sorry, this is going to be, yeah, this will point to element number 3. Why? Because we have to point to the according to the pointers, the index actually. Okay, so the 2 will point to element number 3. Okay, so just to remind, these number 1, 2, 3, 4, 2 are the nums of nums. Okay, like the element of integer, element of this array. Okay, now let's look at this problem once again. So this is the point where uh, cycle begin. Okay, and we have to determine this. So let's move ahead. So how we will solve this problem? So what Floyd cycle algorithm says that you will keep 2 pointers. One is slow and another one is fast. Okay, slow will move one steps at a time, but fast will move 2 steps at a time. So if slow will first go here, and then it will go here 2 steps, and 3 step it has been taken, let's suppose. Then fast will take 1 step, 2 steps, okay, and third step will again be like this. So you can see here that this is the point where slow and fast pointers meet first time. So Floyd cycle algorithm says that determine the, so it has 2 phase basically, first phase if I talk, and second phase. Okay, the first phase says that determine position where slow and fast pointers meet. Okay, and second phase says that keep your slow pointer where the first time meet. Okay, slow pointer, and create another slow pointer, let's call it slow 1, and this will start from the beginning of your array. And now when the position where the both slow 1 and slow 2 will meet, slow 1 will meet, this will going to be your beginning of cycle. So this is the concept of this Floyd cycle algorithm. So let's create one additional slow pointer. So this is slow pointer again. It will come here 1, till that time my slow will move here. Okay, and then this move here, this will then move here. Okay, till that time this slow will move at this position. Okay, so we can say that this is the number where the pointers are meeting. Okay, so this is the where the cycle is has been created. Okay, and and along with this pointers, we have to determine the index. So if you look at along with this number, the pointer number 2 is there, so we will say the index 2 is our answer. Okay, I hope you are able to understand this fluid cycle algorithm. We will also look at the math behind this problem, but before it, the most important part here that a fluid cycle algorithm has two phases. One phase says that determine the position where the slow and fast pointers meets first time. Second phase is that create another slow pointer, slow one, and start your slow one from the beginning of your link array. And whenever the slow one and slow one will meet, it will be your beginning of cycle. Okay, and the element you will get, okay, here we are getting 3, and you just determine the index of that element, and that will be our answer. Okay, now uh, let's look at the math behind it. So if you see, we have two pointers, slow and fast. Both will start from this position, slow and fast. Now uh, let's look at the second phase of this. Okay, second phase of algorithm. What does it says? So it says that let's suppose this is the position where you have determined that your slow and fast will meet. Basically, the first phase of algorithm has been completed at here. Okay, so this is the point where slow and fast met. Okay, if this is the point, then the second phase of algorithm says that this x will and p will be equal, because if this is the beginning of cycle, then uh, p will be equals to x, right? Then only this will going to be meet at a beginning of cycle. Okay, so let's take this is p, this is x, and the cycle length is c. Then c, this will be c minus x. Okay, and we have to we are saying p equals to x, we have to prove it. Okay, yeah, we know that one thing, uh, slow pointers 2 times slow pointer will be equals to fast. This is how we are applying our first phase of algorithms, correct? If this is true, okay, then we know what will be the slow. The slow pointer will move. Okay, the slow pointer will move. Just a second. P plus c minus x. Yeah. So the slow pointer will move actually p plus c minus x time. Correct. And the fast pointers will going to be uh, p plus c minus x plus c. Okay, so the fast pointer we're going to be p plus c minus x. Okay, and plus a complete one more cycle actually. Okay, so if we use this formula, you will get at the end of the day that p will be equals to x. Okay, I hope I able to explain this to you guys. So let's work on the code. So this code says that create two pointers, slow and fast. Initially both will be at initial position. So if this is my cycle, okay, and yep, so initially both slow and fast will be here, while two slow will be equals to nums of slow. So basically we are saying we are saying that slow will take the steps of slow, while the fast will take the steps of 2 times. Okay, so till slow will move here, fast will move here 2 steps. That's why we are using nums, and within nums we are using nums of fast. Okay, so this is the way. So this will take 1 steps and this will take 2 steps. Okay, and we are breaking this loop on the basis of whenever the slow and fast will meet. So if I just uh, repeat, so basically this is our first phase of algorithm. Okay, and then we are creating another pointer which is slow 2. Okay, and till that time, let's suppose this is over uh, where the first meeting slow and fast are meeting. Okay, so we will create slow 2 here. Okay, so we have created, and then we are saying the slow 1 will take 1 step at a time, and slow 2 will also take 1 step at a time. Okay, and whenever the slow and slow 2 will meet, we have to return the index of slow. Okay, so most of it will meet at here, because this algorithm says that the slow 2 and slow will meet at the beginning of cycle, and we will return the index of it. Okay, so, and let's talk about the time complexity of this problem. The time complexity of this problem is O of n, and space complexity will be O of 1 constant. Okay, let's once again look at this problem. So we look at this problem that we says that we have given an array which is containing n plus 1 integer, and each integer lies between 1 to n. So if this is the scenario, we look at that there will be possibility of one number which will going to be repeat, and the problem itself says that only one element is only repeated. And so we have looked at this problem. We take this example 1 2 3 4, and we can see that the 2 element is repeating. Then we says that assume that these numbers are as a pointer, so this will point to the according to the index, and we know, like, if these numbers lie between 1 to n, then this will definitely going to be point somewhere to this block, right? Because these numbers lie between 1 to n, and the index are in the range of 1 to n, 0 to n. Okay, yeah. So yeah, so that then we have created uh, the chart of this, how it will look, and then we apply the fluid cycle algorithm. It has 2 phases. First phase is that determine the position where slow and fast pointer meet at a first time. Slow pointer take 1 step at a time. Fast pointer will take 2 steps at a time. Okay, and the second phase of this algorithm says that create another slow pointers which will be start from beginning. Okay, and uh, and and, and move these 2 pointers, and whenever it will meet, that will be the beginning of cycle, and along with that beginning of cycle you just return the pointer, the index, sorry. Yeah, okay, and then we look at the math behind this problem and we solve it. I hope I able to explain to you. Thank you so much.